In today's session, I will be discussing about the qualitative analysis of organic compounds. Whenever we discuss about analysis can be classified into two: qualitative analysis, quantitative analysis. Qualitative analysis means that is we have to identify what are the elements present in the given organic compound. So what are present, that is qualitative analysis. Quantitative analysis means how much they are present. So these are the two analyses we are going to discuss. At the outset, I will be explaining about the qualitative analysis, that is nothing but the identity test. We have to detect the presence of the elements in organic compounds. Usually in carbon-based compounds or organic compounds, what are the elements present? Carbon, hydrogen, oxygen, nitrogen, halogen. So these are the major elements. So we will discuss one by one. Okay. So first of all, we need to discuss about the detection of carbon. That is point number one. Detection of carbon and hydrogen, because that makes the backbone of the organic compound. Is it not? When you say methane means CH4, ethane means C2H6. So likewise it goes on. Then, so we have to detect first of all the carbon and hydrogen. Secondly, we need to discuss about the other elements, that is detecting of other elements. Usually nitrogen is detected by Lassaine's tests, and there is another test for sulfur also. Then there will be a test for phosphorus. Okay, then there are some tests associated with the halogens also. So let us discuss one by one. Let us take up first the carbon and hydrogen. So here it is given detection of carbon and hydrogen. So carbon and hydrogen are detected by heating the compound. So whenever we heat the compound with copper 2 oxide. So copper 2 oxide, how to represent copper 2 oxide? See, that is, you say copper 2 oxide. Copper 2, Roman letter 2 oxide. Okay. So Cu and its oxidation state is +2, copper. Then oxide O2 minus. So you can write the molecular formula as CuO. Right. So this is copper 2 oxide. So what we are supposed to do, we have to treat this carbon based compound, that is organic compound. So let us assume that it has got carbon and hydrogen essentially. So carbon, when it is treated with the CuO, so CuO, we have to take a platinum board and then we have to heat, okay, the organic compound that contains a carbon. Let me say this organic compound consists of, that is carbon and hydrogen. So in that case, the carbon from organic compound that reacts with the copper oxide, that's what given here, that is heated, so that this copper becomes carbon becomes a carbon dioxide, CO2 plus, and this Cu is reduced. Is it not? Why? Because a removal of oxygen is reduction, and as far as carbon is concerned, it is undergoing oxidation. Oxygen is added, so carbon dioxide. Is it clear? Now we have to balance this equation. Is it not? So you have here, that is O2 here, whereas here you got only O. So you can multiply this by 2. Okay, but this becomes 2Cu, so you can write here. And finally you can write this as a balanced equation. Okay, so this is the carbon from organic compound, and that is treated with what? The copper oxide, 2 oxide. So when it is heated, you are able to get copper oxide plus 2 carbon. So carbon, what is the color of copper oxide? It is a black. Okay, so the black becomes a red. So that indicates, it's a change of color, no? That indicates the copper oxide where from oxygen is removed, and this oxygen is added to the carbon so that you can find the carbon dioxide as gas. Okay, so this is one aspect. The next one is the same organic compound may be having hydrogen also. In that case, how it is going to react with the copper oxide CuO. So the same is applicable here. Hydrogen combines with oxygen, so it forms water, and then Cu is removed as copper, okay, from copper oxide. Once again we had to balance. Now we have got this is H2 and this is 2 hydrogen. So 2 hydrogen plus O, H2O, Cu is left. And this hydrogen may not be available as an molecular form, that is not as H2. Probably it may contain 2 hydrogen. So you can put as an atomic hydrogen also. Okay, right. And then now based on the carbon dioxide, okay, based on the carbon dioxide liberated, we cannot simply, that is, evaluate or determine the weight of carbon dioxide. So the best thing is this can be converted into calcium carbonate by treating with calcium hydroxide. So calcium hydroxide, CaOH twice, calcium hydroxide. Okay, this is the lime water, and carbon dioxide gas, whatever the carbon dioxide passed or obtained as a gas is passed through calcium hydroxide, that is lime water, that turns into milky. That is because of what?
Presence of carbon
dioxide. So CaCO3, that is not soluble in water, whereas this is soluble. So this is a clear water, lime water, that turns into milk. It's called lime water turns to milk, LTM simply you can say. Okay, and with the removal of water also. Okay, are you able to follow? And then now the water molecule, H2O, because we have got this water molecule from hydrogen. So how to determine that one? That is, you have to take 5 moles of water, that is a balanced one, and that is treated with anhydrous copper sulfate. This is anhydrous copper sulfate. Anhydrous copper sulfate is blue in color, white in color. Anhydrous is white. Anhydrous, no water is there. Hydra means water. So anhydrous copper sulfate. And by combining with the 5 moles of water, it becomes what? Cyan blue. So from this you can identify that it has got 5 moles of water. Okay, this is a blue color, cyan blue, copper sulfate. This is a hydrous one, pentahydrate. This is called copper sulfate pentahydrate. Okay, so let me summarize this. How to identify the carbon and hydrogen present in the given organic substance. Let me say this is the organic substance, and we are going to identify the presence of carbon and hydrogen. For carbon, what we have for both of these elements, so we can treat this with copper oxide, so that you are able to get what? That is, in this case, you are able to get copper is separated, and here you are able to get CO2 is liberated as gas. And what about this? In this case, you are able to get
H2.
What? That is H2O, and with the copper. Okay, so this water molecule is treated with anhydrous copper sulfate, so that you are able to get a blue color. Okay, so copper sulfate pentahydrate. Okay, whereas in this case this is combined with what? Lime water, CaOH twice, calcium hydroxide, so that you are able to get the lime water turns to milk, so it becomes a calcium carbonate. Okay, right? So these are the identity tests. So if the organic compounds are given, definitely it will give, because it essentially contains carbon and hydrogen. So this is the test for carbon and hydrogen. Is it clear now?
Yes.
Right. So you have to make a block diagram like this, so that it will be very comfortable, and write down the reaction. These parts are very important. Okay.
Yes.
Then, and based on this you can develop there is flashcard also. Okay. Now let us move to the second aspect. Detection of what? Detection of other elements like nitrogen. In the case of nitrogen, let us consider nitrogen, our organic compound contains nitrogen. We are going to detect this. So what we do is, that is, you have to do the, you've got a fusion tube like this, is also called extraction tube, fusion tube. Now it's a small test tube like material, it's a small test tube you can say, and where you have to take the organic compound here. Okay, and you can take another, instead of taking organic compound first, you can take the sodium metal also. Okay, so the elements are present or converted into sulfur, nitrogen, sulfur, halogen, these are all the other elements. Now we are going to fuse the organic compound with the sodium metal. So for which what we are going to do, take the organic compound, and before that you have to take the sodium also. So sodium, and it consists of organic compound. Okay, so let us melt it under the, that is, you have to put the Bunsen burner like this, you can heat it. Now it becomes red hot, and this red hot tube, once it has formed, it means what, it is fused with the sodium, molten sodium. Okay, and that is dropped into water in a beaker. So when you drop this, what happens, that is, it is broken into pieces, is it not? Yes. Now you can grind it and extract it. So that is called sodium extract. It means that contains, what are the elements? It contains carbon, nitrogen, sulfur and halogen if they are present. And we are targeting nitrogen. So in that case, nitrogen is present means you will definitely have nitrogen in this extract also. Now we have CNS, and how it is going to form, you have got sodium, carbon, nitrogen, so it becomes sodium cyanide. Are you able to follow? Yes. NaCN. This is the first one you should understand. Okay, and then here the sodium, suppose if our organic compound contains sulfur, so it becomes what? Na2S, sodium sulfide. What is this? Sodium cyanide. What is this? Sodium sulfide. Suppose if our organic compound contains a halogen, halogen means what? It can be chlorine, bromine, iodine. Okay, so it becomes the relevant halide, sodium halide. If it is chloride, sodium chloride. If it is bromide, sodium bromide. If it is iodide, sodium iodide. Likewise it forms. Okay, so what we do in the Lassaine's test, it's called Lassaine's test, Lassaine's. So Lassaine's test, don't forget this. So in Lassaine's test, what we do, we take the sodium extraction tube and put all this sodium and what is this, organic compound. The organic compound contains carbon, sulfur, nitrogen, etc. So when it is heated and dropped into water, it becomes the extract, so that they fuse together and forms the sodium cyanide, sodium sulfide, sodium halide. Got it? So now we have to detect, because we have to check whether nitrogen is present or not. Okay, so in that case what we can do, let us assume nitrogen is present. Okay, so this sodium fusion extract, what we have to do is, we have to boil this extract. What is this extract? Sodium fusion extract. What does it contain? Essentially it contains what? Cyanide, is it not?
Yes, sir.
It should have some cyanide ion. So we have to take this and acidify with sulfuric acid. You have to add sulfuric acid, H2SO4. Okay, so that it immediately forms what? Your Prussian blue color. It is boiling actually. Okay, so Prussian blue color. So when you are able to get the Prussian blue color, means it indicates it has what? Nitrogen. Okay, so now let us talk about the chemistry of this test also. Okay, so if it is a Prussian blue color is obtained, it indicates that the nitrogen is present. Now sodium cyanide Sodium cyanide, now we have got its NaCN. This can be written as Na plus Cn minus, and let me consider the Cn minus, so a cyanide ion. That is reacting with what? Fe. Okay, so sodium cyanide first reacts with the iron 2 sulfate. Okay, so Fe2 plus to give, if you got any ferrous sulfate, iron sulfate is added, so you are able to get ferrous cyanide, hexacyanoferrate, or FeCN is a complex ion. Okay, we will get this compound, and this hexacyanoferrate ion, that reacts once again with iron, the same thing, Fe, you can write like this, Fe, and then Cn 6 times 4 minus, not plus, 4 minus. Okay, so that reacts with Fe, ferric ion. Here Fe2 plus ion, ferrous ion, this is ferric ion. So definitely this is 3 plus, this is 4 and minus, you can exchange it. This is 4 and this will be 3. So the 3 4s are 12, 4 3s are 12, balanced. Okay, so we are able to get, and it will form with the x moles of water also, so that you are able to get Fe 4 times, and once again Fe, okay, Cn 6 times, okay, 6 times and 3 with x moles of water. Actually this is called a complex compound, the coordination compound. We will be discussing in the next year in detail about this coordination compound, because it forms a coordination bond and is also called a complex compound, and the chemistry based on this is also called complex chemistry or coordination chemistry. Okay, right. So this is the salt or the substance or compound called Prussian blue. So the color developed is due to the formation of Prussian blue. Is it clear now?
Yes, sir.
So how to test for nitrogen? What we are supposed to do?
Adding
You can treat it with the sodium extract, so that you will be having cyanide ion, and you can treat it with that is in presence of some ferrous ion. You can add acidified substance, so that you are able to get this hexacyanoferrate ion, and that combines once again with the ferric salt, okay, ferric chloride, something like that, then it becomes Prussian blue. Is it clear? So this is the identity test for what?
nitrogen.
Nitrogen. So now let us summarize. Okay, so how to that is, actually we are adding two types of iron salts in acidified condition, so that is the very important aspect here. So one is, so first what we take, organic compound that contains nitrogen, and then we add sodium, melt it, so that you are able to get sodium fusion, what is that, extract by boiling, and that portion, a small portion of this one can be taken, and that is further treated in the acidified condition and followed by the addition of Fe2 plus and Fe3 plus salts. It can be ferrous salt and ferric salt, ferrous chloride or ferric chloride, so that you are able to get first what? The FeCN6 ion, ferric based Cn6 ion, 4 minus, and followed by the Prussian blue by adding Fe3 plus in the next stage. First stage ferrous chloride, next stage ferric chloride. Are you able to follow? And you should be able to recollect or remember the formula of Prussian blue also, which is nothing but Fe4, what is that? FeCN 6 times. This is called hexacyanoferrate, and its valency is 4 minus, so you can put 4. This is ferric ion, so you can put 3, that's all. Okay,
Yes.
and along with that x moles of water is added, so x hydrated salt, and its color is blue color. So by the formation of blue color, you can say that it contains
Nitrogen.
nitrogen. Is it clear now? Right. Next. And what about the other ions here, see there is, suppose if it has a sulfur, okay, it can react with lead. Are you able to follow?
Yes.
So what you have to do, you can take the sodium fusion extract, the same fusion extract, and add the lead salt, like lead sulfate, lead chloride, etc. So you can add lead sulfate. When you add lead sulfate, it becomes lead sulfide. So lead sulfide is black in color. So by the formation of black color, you can say it contains sulfur. Clear? And similarly, now you are taking the sodium fusion extract and you have to add sodium nitroprusside. So the sodium nitroprusside, okay, along with that, now violet color is obtained. So when violet color is obtained, it indicates the presence of sulfur also once again. Okay. Then sometimes a sodium, you have got sodium, carbon, nitrogen, sulfur. It becomes what? Sodium. This is called sodium thiocyanate. Thiocyanate. Okay. So this sodium thiocyanate, thio means a sulfur. Okay. So this cyanide can combine with the sulfur and the sodium, it becomes sodium thiocyanate, and this thiocyanate can once again react with the ferric ion, that we add ferric chloride or ferric salt, so that you are able to get blood color. So from this also you can say it contains what?
Sulfur.
Sulfur and nitrogen. So this indicates the presence of both sulfur and nitrogen. Then now once again this is sodium thiocyanate when it is extracted, so that you are able to get sodium cyanide, and the sodium sulfide is separated here. Okay, so likewise, and suppose you can take the same extract and treat it with the silver nitrate, AgNO3. So when it is treated with the AgNO3, Ag has more affinity towards chlorine or halide, so it becomes a silver halide. So white precipitate is obtained. If you have got yellow precipitate, it can be chromide. So likewise you can judge. Okay. So the presence of chloride also can be identified based on this Lassonde test. So what is the use of Lassonde test? With the help of this, we can have we can identify what are those? Nitrogen, sulfur, and then halides. Okay. So all of them can be identified based on this. Okay. So for which we have got various stages. And test for phosphorus. So in the case of phosphorus, okay, the compound is heated with oxidizing agent, sodium peroxide. What is sodium peroxide? That is sodium peroxide. Actually that is H2O2 is hydrogen peroxide. Okay. Yeah. So in that case we have to take the sodium peroxide, and that is the powerful oxidizing agent. So in presence of any peroxide, okay, peroxide, it can react. Suppose phosphorus is present in the organic compound, means then it is triggered as what? Phosphate in presence of this oxidizing agent. Okay. So once you are able to get phosphate, you should try to understand about this phosphate. That is a PO4 3 minus is phosphate, and you have got already sodium. So by combining this, now 3Na, so Na3 PO4, is it not? This is called sodium phosphate. So this sodium phosphate is further treated with a nitric acid, so that you are able to get phosphoric acid. The sodium is replaced. Okay, so that you are able to get phosphoric acid is called orthophosphoric acid, H3PO4. So this 3 cations of sodium is replaced by 3 protons, H plus, and thereby you are able to get phosphoric acid with the formation of sodium nitrate NaNO3 also. And again, phosphoric acid can be combined with ammonium molybdate, so that in presence of nitric acid you are able to get ammonium phosphomolybdate. Okay, this is an yellow color precipitate. Okay, so by the formation of this yellow color precipitate, you can confirm that it is having phosphorus. Okay, other than phosphorus, these elements will not react, so that you can confirm that it contains phosphorus. Okay, so the formation of yellow color, because of the formation of what?
Yellow color.
Ammonium phosphomolybdate. What is the formula? Ammonium phosphomolybdate. Molybdate is MoO3, Phosphate is PO4 3 minus, PO4. Okay, so by combining this, you are able to get ammonium, that is trivalent. This is monovalent actually, NH4, but there will be 3 ammonium ion, and that's why it's called ammonium. See, NH3 is ammonia. This is ammonium. NH4 plus is ammonium ion. Okay, ammonium ion. NH4 plus is ammonium ion. So likewise, 3 NH4, 3 moles of NH4 plus comes, and 1 mole of, 12 moles of molybdate along with the PO4. Okay, because PO4 is a 3 minus. See, it can combine like this, NH4 plus. What about this? PO4 3 minus. Okay, now 3 minus, so you have to multiply this by 3, so that you are able to get NH4 and then 3 times, then PO4, that's all. Along with that, you have got 12 moles of molybdate. Molybdate is MoO3. Molybdenum, then it's oxide, so O3. Are you able to follow? And that is why it's called, what is that? Ammonium phosphate, and this is molybdate. So you can combine this. So ammonium phosphomolybdate, that's all. Okay, and this is a yellow precipitate. So by the formation of this yellow precipitate, you can confirm that our organic compound consists of some phosphorus. Okay, so let me summarize what are the tests we have discussed today. That is, an organic compound may consist of carbon, hydrogen, and then oxygen, then sulfur, nitrogen, halogen, and then phosphorus. Now, for example, carbon and hydrogen, okay, can be identified by what?
C. Copper oxide.
Yeah, by adding with the copper oxide, and all this Sc, Sn, X, okay, can be identified by what? Lazane's test, LT, Lazane test, where what we have done, we took the sodium extract, okay, sodium metal, we fuse it, so we use that sodium extract in different manners. Okay, so and based on the appearance of the color, we can identify the presence of nitrogen, sulfur, and then carbon, and the combination of sulfur and nitrogen also, that gives you blood red color. Okay.